So this is translating absolute value expressions. Example A says all real numbers whose distance from 0 is greater than 4. So when we think about this, all real numbers, so we're just going to call that x, whose distance from 0. So when we think about distance from 0, okay, distance means we're going to be taking the absolute value of this thing. From 0 means minus 0. So what we're going to get here, all real numbers whose distance from 0. So the absolute value, distance, from 0. So we want x minus 0, because that's our distance from 0, is greater than 4. So we want this distance to be greater than 4. Now we're going to clean this up a little bit because we know that x minus 0 is just x if we're not taking anything away. So what we actually get is the absolute value of x is greater than 4. Another way to remember this is that distance from 0 is the definition of our absolute value. So in part B, where it says all real numbers whose distance from 0 is at least 9. So distance from 0, we know that's going to be the absolute value of x, all real numbers whose distance from 0. And then it says is at least 9. So it can be greater than 9, it can be equal to 9. It has to be at least 9. So greater than or equal to means at least 9. In part C, it says all real numbers whose distance from 5. So this is different. It's not distance from 0, it's distance from 5. So all real numbers whose distance from 5 is at most 14. Well, if we look at the first one, when we did distance from 0, we had x minus 0. So distance from 5 is going to give us x minus 5 within the absolute value. So all real numbers whose distance from 5, so that's x minus 5, is at most 14. So when it says the distance from 5 can be at most 14, that means it can be less than 5 and it can be equal. Okay? So distance from 5 at most 14. So it can be less than 14, that's fine, and it can be equal to 14, that's also fine. The only thing that we can't have is if the distance is at most 14, it can't be greater than that. So here is our inequality. The absolute value of x minus 5 is either less than or equal to 14. In part D, the problem at first looks complicated, but it's really not too bad if we remember the formulas. So let's go ahead and read this through. A 20-ounce bottle of soda may not contain exactly 20 ounces of soda. The possibility of measurement error exists when the bottle is filled in the factory. If the maximum measurement error is plus or minus 0.25 ounces, write an absolute value inequality representing the range of volumes x in which the soda bottle may be filled. Okay. So we're being asked to write an absolute value inequality representing the range of volumes. So when we do this, we have our formula. And that is that the absolute value of the actual measurement, which I'll just call actual, minus the ideal, what we would actually like the bottle to be filled to, needs to be less than or equal to the amount of error that we allow. So here we don't know the actual value, what's actually in the bottle, so we're going to call that x, minus the ideal. We do know what we want the bottle to be filled with. We want it to be filled with 20 ounces of soda, so it's x minus 20. So what this is saying is if there's 20.01 ounces, that's the actual value, minus the ideal, which was 20 dead on, we want that to be less than or equal to the error. And in this case, we're told that the error is plus or minus 0.25. So we write 0.25. And that is our absolute value inequality. And that's going to give us the range of values.